Good morning guys, I hope you're well. Today we're going to be learning how to calculate the volume of a prism. Okay, so let's start off by recapping what a prism actually means. So it's just a 3D object whose cross-section is the same all throughout its length. So by cross-section, I mean just this face on the end. So for example, if you look at this hexagonal prism, it is a hexagon on the front face and the back face. And if you imagine, let's say this shape was a cake, and if you've got a knife, no matter where you chopped this cake, you would always see that hexagon in the middle. So it's that hexagon shape, it runs consistently all throughout the shape in the same size. So same with the pentagonal prism or a rectangular prism, which is obviously the cuboid. Right? So have a look at this shape. Is this a type of prism? Well, no, it's not. Some people might think it is a prism because if you cut it, say, horizontally, the base would always be a square, wouldn't it? But the square is going to be much larger on the base of this object compared to, say, halfway up. Because that square is not the same length, this is not a type of prism because it doesn't have that consistent cross-section. Would this shape be a prism? Well, yes, it would be. So this is an example of a triangular prism because it does have that triangle cross-section, so it looks like an equilateral triangle to me. And no matter where I chopped up this Toblerone shape, it would always have that perfect equilateral triangle in the same shape and size all the way through. Would this be a prism? Well, clearly this is not a prism because it doesn't have a consistent cross-section. But could you turn this into a prism? So think to yourself, how could you turn this into a prism by cutting this shape twice? Well, if you were to chop off the end of this pencil, and if you were to chop it off here just before you get to the metal bit, you might have, say, I don't know, it looks maybe like an octagonal prism, something like that. So it's nearly a prism, but it's just the fact that that cross-section is not consistent, which makes this shape not a prism yet. Okay, so thinking about our formulae, we're going to learn another one now. So the volume of any prism is just the area of that cross-section multiplied by the depth. By cross-section, I just mean that face on the front and back. So the area of this shape, so this square, multiplied by the depth. And by depth, we mean that length that is perfectly perpendicular to the cross-section. So basically the one that's going away from the cross-section. Alright, so please could you make a note of this formula? So write it down, add it to your formula sheet, just so you've got all of these formulae in the same place. Okay, so let's try an example together. So remember, volume is the area of the cross-section multiplied by the depth. Here we have a triangular prism, and we want to calculate the volume of it. If you just want to try it now, just pause the video, or if you are unsure and you want to listen to me explain it, just leave it running. Okay, so the area of a cross-section, well, my cross-section here is the triangle. How do I find the area of this triangle? I'll do the base times by the height and half it. 11 is the base. Which one's the height? Is it the 8 or is it the 9? The height must be vertical, so I'm going to do 11 times by 8 and half it. Okay, so half of 88 is 44, so the area of my cross-section is 44. So I'm nearly there, but now I need to multiply it by the depth. The depth is the length that faces perpendicular from the cross-section. So the depth is basically how long that prism is. It's 20 centimeters long. So I'm going to do 44 multiplied by 20. That gives me 880 and a centimeter cubed. Centimeter cubed because I'm looking for volume. And that's my final answer. Okay, so on your sheet on Google Classroom, please can you work your way through task 1. You don't need to do every single one. I think a reasonable amount of time to spend on this is about 10 minutes or so. You want to spend most of the lesson on task 2. So spend 10 minutes on task 1 and then come back to this video and I'll talk you through task 2. Okay, so we've got a cylinder. Is this a prism? Well, yes it is. Yes, so it is a cylinder, but a cylinder is a type of prism. We know it's a type of prism because it's got that same cross-section all the way through. So the cross-section is a circle. No matter where you chop that cylinder, it would still have that circular cross-section in the same shape and size. Alright, so how would I find the volume of a cylinder? Well, we know that a cylinder is just a type of prism, so I just find the area of the cross-section and multiply it by the depth. So basically, it's pi r squared because it's a circle and multiply it by the depth. So some people like to remember this special formula for a cylinder, but I don't even remember this off by heart because the volume of a prism just covers any prism, and the cylinder is a prism, so you could make note of this formula, but I tend to just remember just the volume of a general prism one and go from there. Okay, so just using my volume of a prism formula, well, how would I find the volume of this first shape? Well, finding the area of my cross section, so it's pi times by 10 squared, because it's a circle with a radius of 10, and then multiply it by my depth, which is 10. So that gives me 1000 pi centimetre cubed, or if I write it as a decimal, it's 3141.6 centimetre cubed when I round it to one decimal place. Please could you pause the video and see if you can calculate the volume of this cylinder. Okay, so our formula is pi r squared multiplied by the depth. We have a circle with a radius of 5, so it's pi times by 5 squared multiplied by 10, so it's 25 pi multiplied by 10, so it's 250 pi centimetre squared. Writing this as a decimal, that could be 785.4 centimetre cubed when I round it to one decimal place. Right, let's try a trickier one. Okay, so our question is, well, given that the volume of a cylinder is 1400 centimetre cubed, let's calculate its height. Okay, so in this question, it gives us the volume, and it wants us to work backwards to calculate the height. Well, let's consider our formula. For the volume of a cylinder, it's pi r squared and multiply it by the depth. All I'm going to do now is substitute in everything I know. So I'm told the volume, so instead of the volume, I'm going to call it 1400, and I'm told the radius, so instead of r, I'm going to call it 8, but I don't know the depth yet. So the depth is that h length that they haven't told us yet. Okay, so 8 squared is 64, so we're just going to call this 64 pi. Okay, but I don't want 64 pi times by h, I just want h on its own. So can you think, what do you think I'm going to do now? How do I get from 64 pi times by h to just h on its own? How do I make this bit go away? Well, what I'm going to do, I'm going to divide by 64 pi. The opposite of multiplication is division. So dividing both sides by 64 pi, that gives me this calculation, and I'm just going to use a calculator to tell me that the height of this shape is 7.0 centimeters when I round it to one decimal place. Okay, and that is my answer. Okay, so now please can you find task 2 on your worksheet. It starts off relatively simple, and then it gets a lot more challenging as you go along. Okay, so make sure you spend 1 hour on this lesson in total. You don't need to do the questions in order, and just let me know if you need any help. Alright, thanks very much guys.